Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and strong. Now, we were studying this chapter, area of parallelogram and triangles, and we have had lots of theorem based on it and numericals we have done it. Okay, now we are going to solve some theorem based on our previous theorem. The theorem was when you're having a median of a triangle, then that median will divide the triangle into two equal triangles. If you are having a triangle, you are having a median of it, this part and this part. That means this triangle and this triangle will be the equal in area. Okay, this we have studied. Now we are going to prove another things based on this theorem. We are going to use this theorem, so it's important to recall it. Okay, so let's see the question. Show that the diagonal of the parallelogram divides into four equal areas of triangle. So that means first we are having a parallelogram, right? Okay, we are having a parallelogram, and let's name it ABCD. Now it's saying diagonal of ABCD will be this AC and this BD. Okay, now it's saying that it is dividing, show that it is dividing it into four equal areas of triangle. That means we have to prove that area, these four areas, this first area, second area, third area and fourth area are basically equal. Okay, so we are going to prove that if this is something we call O, okay, then we have to prove that AOB area, AOB is equals to area. The second one, OBC or BOC. And the third area, which is COD, is equals to area of AOD. Understood? This we have to prove. Okay, so now proof. Construction section, you can say that meet B to D and A to C to find the diagonals of parallelogram. Now about the proof part, what we are going to do, we are going to pick this complete big triangle, okay, and this complete big triangle, and then we are going to use the median concept in order to prove it all equal to each other. Okay, let's see how it's done. Now in triangle, I am taking the big triangle ABC, okay. So the triangle I am talking about is this. Okay, this is the triangle we are talking about. Now in this triangle, what's happening? CA and DB is the median, is the diagonal of the parallelogram. The parallelograms diagonal intersect each other and also bisect each other. Okay, so that means at this point AO is equals to OC and DO is equals to OB, right? Okay. AO is equals to OC. These two are equal. Why so? Diagonals of parallelogram intersect each other. But what benefit are we getting from this? Look, if AO is equals to OC, that means OB is dividing it into two equal halves, right? And if OB is dividing this side of a triangle in two equal halves, that means OB is the median, right? That means OB is the median of triangle ABC. This implies area BOC is equals to, what I am telling you, that these two areas will be equal to each other, right? Okay. Area AOB, this is the first we are getting. Similarly, if we are taking this triangle ADC, in the triangle ADC, with the same thing, these two are what, equal? Okay, so that will be the median. OD is median. That means these two triangles, dear students, these two triangles, this is the first triangle, this is the first triangle, and this is the second triangle, right, are equal. Area AOD is equals to area COD, right? This is the second thing. Okay, these two are equal, these two are equal. That means 1 is equals to 2 and 3 equals to 4. Now, look here, if I'll take this complete triangle, if I'm taking this complete triangle, then my dear students, in triangle ADB, same thing, OD is equals to OB, okay, because of the same reason diagonals of parallelogram intersect each other. Write it, diagonals of parallelogram intersects. This is not intersect, student, this is bisect, okay, mark it, it is bisect here, okay, it bisect, okay, this is because it's being two equal halves, bisects here also, bisects each other, okay. This implies that this AO is median, and by this AO is equals to median, we have this triangle AOD, area of triangle AOD is equals to area of triangle AOB, right? And this is the third equation, okay. So, by equation 1, 2 and 3, we will be seeing these three equations, okay. We are going to rub just some section of it. Okay. Now look at the first, second and third equation. Area BOC is equals to area AOB from the first one. Okay. Now, area AOB is equals to area AOD. Okay. So, this area AOB is equals to area AOD. Area AOB is to area AOD. Okay. And this area AOD here is equals to area COD, is equals to area COD. Okay, this was something we had to prove. Okay, these 4 triangles BOC. See here, BOC, BOC. This is the second one. Okay, then area AOB, this is the first one. Okay, then area AOD, this is the fourth one, and area COD is the third one. First, second, third, and fourth. 4 areas are equal to each other now. So here our question has been solved, right? Now the next, in figure ABC and ABD are 2 triangles on the same base AB. We are giving this complete diagram. We are having no parallelogram here. We are going to use only the medium theorem in this question. Okay, so what it is saying that 2 triangles on the same base AB, if line segment CD is bisected by AO. Line segment CD is bisected by AO, that means these two line segments CO and OD are equal to each other. Okay, at O, show that triangle area ABC. What is area ABC? Let's mark ABC. This area, we have to prove that this area is equals to ABD. Okay, these two triangles are equal to each other. Okay, so what we can do, we can just take this triangle first and then we are going to take this triangle. Okay, then we will prove. So we are taking this triangle and this triangle. Okay, and meanwhile we are provided with the information that these two are equal. So we are going to apply the median concept. Okay, or else we can say that proof we are having. In triangle ACD and DCB, in both the triangles, for both the triangles, CO is equals to OD. CO is equals to OD. That means O is the midpoint of this, and for that AO is the median here and OB is the median here. This implies that AO is median of triangle ACD and OD, not OD but OB. OB is the median of triangle DCB. Understood? Now, we are going to talk about these two areas, right? So, area AOC is equals to area AOD. I am saying that these two areas are basically equal to each other. And why so? Because AO is median. Of triangle ACD. Similarly, we can say in this big triangle CBO or OCB, BOC, this area is equals to this area, this triangle area. So that is BOD area, BOD. Okay, so if this is the first equation, that will be the second, and the reason will be the same, that OB is the median of this triangle CBD, right? Okay, now by equation 1 plus 2, add both the equations, we are going to have area AOC, this area AOC, okay. We have to prove ABC. In order to prove ABC, we are going to have this complete triangle, okay. So, we'll be adding this to this side, area BOC. These two have been done, right. Now, with this is equals to area AOD plus area BOD. Now, take a look what areas these two areas are making. I am showing it in pink color. Okay, AOC and BOC. So, AOC and BOC, right. These two areas are making this big area ABC. So, this is the area ABC here. Okay, area ABC. Now, the next one is area AOD. Now, area AOD is this area, okay, plus area BOD. BOD is this area, okay. So, now look, this area is making this ABD, okay, is equals to area ABD, and that we had to prove. So, that is our final solution to this question. Okay, note it. Okay, so in this question we are given the DEF, that DEF are respectively the midpoints of side BCC and AAB. So, we are having a triangle over there, and the midpoints points of which are D, E and F. So, I am having this side BC, and the midpoint of BC is D. Then I am having the side CA, and the midpoint is E. And then I am having a side AB, whose midpoint is F. Okay. So, basically I have to first show that this BDEF is a parallelogram. So, BDE, it's E here, and here F is a parallelogram. Okay. So, for the first part, we are having students here, this F is the midpoint of AB, F is midpoint of AB, right, and we are having, this is the midpoint of AB, and we are having the midpoint of AC is equals to E, and E is the midpoint of AC. Sorry. Now, understand this F is the midpoint of AB, and we are having E as the midpoint of this AC. That means these two midpoint are joining. So, that means EF is the line segment made by joining midpoints of AB and AC. Okay, that means EF, this EF will be parallel to this EF will be parallel to this BC. Understood? First thing. Right. Now, we had proved about these two things. Now, we are going to take this BA and ED. Right. So, BA is the line here. Now, E is the midpoint of AC. Similarly, E is midpoint of AC and E is the midpoint of AC and D is midpoint of BC and D is midpoint of BC. So, this is the midpoint here and this is the midpoint here. Okay, and we are talking in respect of this AB line. So, this ED will be what? Parallel to AB. This implies that ED will be parallel to FB because parts of parallel line are also parallel. Okay, this implies that these two lines are parallel and these two lines are parallel. So, this figure made BDEF, this BDEF should be a parallelogram then? Okay, so we are going to write the same here. This implies that BDEF is a parallelogram. Second part. A, B and C. For BC it is D here. For AC it is E here and here it is F. This was our diagram. Now, it's saying they show that area DEF is equals to 1/4 area ABC. Okay. DEF area. So, there is a triangle here now. Okay. From the first, we had proved that BDEF, this is a parallelogram. Right? BDF is parallelogram and this implies that this area is equals to this area. Okay? Area BDF is equals to area FED. Area DEF. Okay, call it DEF. These two areas are equal. Now, similarly, we can prove that this area EFCD is also a parallelogram. Similarly, we can prove that just as we have proven in the very first thing. Okay, here BD is a parallelogram, so we can also have this DFEC as a parallelogram. Okay, DCEF is parallelogram. This is the first equation. Okay, students. Now, for this we are having DEF equals to area DEF is equals to area EDC. And second thing. Now, we are having one more parallelogram here. Similarly, you can also prove that EFCD, AEDF. Okay, so this area AEDF is also a parallelogram, which implies that this area DEF is equals to area AFE. This is the first, second and third equation. Okay, by first, second and third. this area is equals to this area, and this area. That means these four areas are equal to each other. Okay, so I can say that area triangle EDF is equals to, from the first equation, is equals to BDF, which is equals to here EDC, which is then is equals to here AFE. Right? We are having these four equals to what? Your area EDF. Right? Now, area triangle ABC is equals to what? These four areas making this complete triangle ABC, this area, this area, this area, and this area. Okay, so that will be equals to area EDF plus area BDF plus area EDC plus area AFE. But these four things are same, equal to each other. Okay. So I can replace here that this implies that area ABC will be equals to what? Area 4 area DEF, because I am going to replace each and everything with the DEF, DEF, DEF. Okay, here DEF. So this area is equals to all these three areas. So I am going to have this 4 area DEF. That implies that area DEF is equals to 1/4 of area ABC. Okay, and this was what we had to prove. Understood? The second is done. Okay, about the third one. This is the point F. Okay, name them again. This was A, here it is B, it was D, and F here. The third one, we have to prove that area BD equals to half area ABC. So from proof second, we are having area DEF is equals to 1/4 area ABC. Okay, now multiply both the side with 2. Then we'll be having 2 area DEF is equals to half area ABC. Now area DEF plus area DEF is equals to half area ABC. You can write it like that also. Now we have to write the area BDEF. Now look at the area BDEF. BDEF. This area is made up of these two triangles. First is The first is DEF. DEF is mentioned here, and second is BDF. BDF. Now BDF and DEF are actually equal. We had proved that in the very first thing. Okay, so we can write also here area DEF plus area BDF is equals to half area ABC. Okay, and by that you can say that this is the area, this complete parallelogram, which is BDEF. BDEF is equals to half area ABC. Hence proved. Okay, done. So this is good for today. We are going to do some more interesting questions in next class. Till then, keep keep watching, keep listening to good quality lectures of ours, and take good care of yourself. Bye bye, students.